What's up everybody, Steve here, and today I'm going to teach you a little bit about sets, specifically unordered sets, also known as hash sets. Sets are a very important data structure. They start appearing as early as bronze, and you're going to absolutely need to know how to work with them. They're very important tools in order to speed up how quickly you can handle collections of things. Feel free to skip forward to the coding section if you already know what sets are and just want to see how to implement them. But we're going to start just by explaining what a set is and when and why you might want to use them. As you can see here, I have some words laid out in front of me. One fish, two fish, red fish, blue fish. Let's say I wanted to have a collection of all of the unique words that occur in this phrase. Well, obviously, as you can see, fish is occurring a bunch of times. If I started building this with some sort of a list or a vector, I would start with 1, and I would put that into my list. I would have fish, and that would go into my list. I would have 2, and that would go into my list. I would have fish. If I'm just using a vector, then prior to inserting fish, I would have to check to see if fish is already in the list. And I would say, okay, oh, that's fish, I don't insert it. Red, I have to check if red is already in the list prior to inserting it. Fish, check if it's in the list prior to inserting it. Blue, check if it's in the list prior to inserting it. Blue can go in the set. And then finally fish, and I find it. Here's where this can be a problem. Let's say I have 1 blue, 2 red, and fish. And I have a bunch more instances of fish that I'm trying to decide if I can insert. So fish, doop, 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 doop. Oh, yeah, we have fish. Fish, doop, 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 doop. Oh, we already have fish. Fish, doop, 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 doop. We already have fish. That's a lot of repeated checking, and you're losing a lot of time complexity here. This is what we call an n-squared situation if we just have a list, because for each item, I have to check each item prior to inserting it. So this is where a set comes in. In particular, an unordered set works by using something called hashing. The way that hashing works is we take the thing that we're inserting, for example, fish, and we come up with some way to represent this using a number, typically a size t. So for example, if you wanted to keep it simple, you could say, well, F, A, B, C, D, E, F, that's the 6th letter of the alphabet. I is A, B, C, H, I, that's the 9th letter of the alphabet. S is A, B, C, D, L, M, N, O, P, Q, R, S, 19, and then H is G, H, 8. And you could take those numbers and add them all together, and that would give you whatever that is. And you would use that number as a representative value of this word. And then what ends up happening is we have, this is all behind the scenes, we have an array with some number of items in it, and we place that into the array based on the number. So let's say the array has 10 spaces. If I came up with 55, I would divide 55 by 10 and get the remainder 5, and I would put that into index 5. Now there's more to it than that, but you don't really need to know it at that level of detail. All you really need to know is that a set will very quickly, in fact, almost instantly, jump to a index in an array and place the item there. So then we have red, we'll jump to whatever index that is and place the item there. 2 will jump to some index and place an item. 1 will jump to some index, place an item. Blue will jump to some index, place an item. Fish jumps to the index and sees that it already has it, so it doesn't. Fish again, doesn't add. Fish again, doesn't add. Each of those inserts is in constant time now rather than linear time because I don't have to check everything. I go straight to an index prior to inserting. There's 2 caveats to this. One is whatever you insert into your structure needs to have some way of turning itself from a organic thing, which could be a struct or a class or whatever, into something numeric. Even if it's a word, we have to somehow turn this word into a number in order to do the insert. And that may mean writing a custom hash function. The other caveat is we need to have a little bit of infrastructure to get this to work. Depending on your language, this may or may not be a little bit tricky. Python does this very naturally. Java does this somewhat naturally. C++ is a little bit clunky in this case. But what's going to be the result of this is you'll have objects that are all able to be inserted into a structure in constant time, to be checked if they're in the structure in constant time, and it'll maintain a unique list of objects. Now, this will work for anything. It'll work for strings, it'll work for integers, it'll work for vectors. Being able to instantly check to see whether or not you've seen that vector before, and to be able to add vectors to a collection and have it automatically discard duplicates is an incredibly powerful programming tool, because that saves you the process of having to iterate through a whole collection of items looking for something. This also is good in situations where your integers are perhaps very large, but we don't want to have a Boolean array with 1 billion indexes. See, if you had a Boolean array with 10 indexes, and you could jump to an index and see whether or not it was true or false, you could use that to maintain a list of unique items. But if the numbers are sufficiently large, or we're dealing with multiple dimensions, having a hash set of integers or a hash set of collections of integers is going to be the most efficient way to do that. I'm going to walk you through the process of using code to create a set and how you can use that for USACO problems. Okay guys, time for the code example. I'm gonna do this in reverse order from what I usually do, starting with Python. The reason I'm going with Python first is because it's pretty easy to understand. And if you're not as familiar with sets, even if you don't know the Python language, it's a relatively straightforward way to kind of get an understanding prior to looking at the Java and the C++ solutions. So in this example, you can see I have a hash set. I'm gonna add 1 and then I'm gonna add 2 twice and print it out to show that the 2 was removed. We're then gonna check to see if 2's in the hash set and 3's in the hash set. We've got 1 and 2, 2's in it, 3's not. All right, here's a simple example in Java. As you can see, I'm adding 1 and then adding 2 twice. We'll print it out to show that the 2 was only added a single time. I'm then gonna check if it contains 2 and check if it contains 3. Java C example. Okay, so I can see 1 and 2, true and false. For the C++ example, I've set up a similar demonstration, inserting 1 and then inserting 2 twice. I'm gonna iterate through and print out all the numbers and then check to see whether or not I can find 2 and whether or not I can find 3. Now it's gonna fuss at me a little bit because of that for int num : thing. However, I think it's still gonna let me run it. Yeah, so the reason why this is happening is I'm not using the C++ extension. I'm using the 2006, I think, is the default compiler. But let me get away with it anyway. Here's a slightly more complex example. We're gonna be using strings this time instead of integers. Again, with the Python, I'm adding 1 and then I'm adding 2 twice and checking to see if 2 and 3 are in the hash set. You can see 1 and 2 are in the set. And we came up with true and false, and that worked great. For Java, you can see very similarly, we've got our hash set, adding 1, 2, and 3, printing it out, and as expected, it's doing the same thing. Finally, in C++, we're gonna do make 1, 2, and then 1, 2. What if we need something far more complicated than this? For example, what if I have X and Y coordinates? Or if I have collections of vectors that have 4, 5, or 6 numbers in them? There's all kinds of situations I might encounter. Fortunately, with Python, this is very easy to do. With Java, it's a little more tricky. With Java, if you're going to be using lists, everything has to be the same data type, whereas Python would let you mix and match strings and integers in the same tuple. With C++, however, we're gonna have to write a custom hashing function. I talked a little bit about that in the beginning, and I'll show you a code example of how to do that. The most that you'll typically run into, and the most common example that you'll have in a USACO bronze or silver, is having either X and Y or X, Y, and Z, 2 integers or 3 integers. I'm gonna go ahead and show you an example using 3 integers. If you wanna do one for 2 integers, all you have to do is delete the third number. It's pretty easy to scale it down. In this case, I'm adding tuples. A Python tuple is kind of like a vector or a list, except it is a fixed size and it's also immediately hashable, which means I don't have to write a custom hash function for this. So what I'm doing with this set is I'm gonna add the numbers 2, 4, 6, then I'm gonna add the numbers 1, 3, 5, then I'm gonna add the numbers 2, 4, 6 again. My expectation is that 2, 4, 6 should occur 1 time and 1, 3, 5 should occur 1 time. Then finally, I'm going to print out whether or not 2, 4, 6 is in the hash set and whether or not 2, 6, 4 is in the hash set. One thing that's important to note is hash sets don't maintain order. As it turns out, dictionaries in Python do. They use some sort of a linking system to maintain dictionary keys in the insertion order, but sets don't. So it's possible that we'll get them not in the same order we insert them. That doesn't matter though, because again, we're only concerned with uniqueness. We're not concerned with order. If uniqueness was, if order was an important thing to us, then we would not be able to use a set. We're gonna do Python 3. You can see here, first off, it prints out 2, 4, 6 and 1, 3, 5. Those are my unique sets. And then it printed out true because it's true that 2, 4, 6 is in the set, and false because 2, 6, 4 is not in the set. Now again, remember, the order of these numbers is maintained because this is a tuple. So 2, 4, 6 is not the same as 2, 6, 4. But when I'm checking if 2, 4, 6 is in the collection, it'll know whether or not it's in the collection uniquely. Just for giggles, I'm gonna change the order here. Yeah, so notice that when I change the order here, if I do 1, 3, 5 first and then 2, 4, 6, I still got 2, 4, 6 first. And the reason why is because there's a hash function that's turning these into a number, which is then becoming the index of where it gets inserted in this under the hood array that's storing these things. Again, we don't have to worry too much about how that works. We just have to trust that when you add things to a hash set, they will be added in a unique way. Duplicates will automatically be removed, and we can check to see whether or not something's in the set in constant time rather than linear time. All right, so now we're gonna move on to Java. Java's a little bit more complicated, but if you're comfortable working with lists And the arrays tool, we can simplify it a lot. Otherwise, we have to make a bunch of array lists and convert them, and it's a big headache. But I can use the arrays tool and do arrays as list 246, and it will produce a list object for me. And it doesn't really matter whether it's an array list or a linked list. I do think the default is an array list, but it shouldn't make a difference because what we need is unique sets of items. And in order to know if they're unique, you have to check all the items anyway. We create our hash set of list of integers as a new hash set. We then can add arrays as list 246, 135, and 246. We will print out the hash set, and we'll print out whether or not the hash set contains 246 and whether or not it contains 264. Java C. You can see with our print statement here, we have 135 and 246. It is true that it contains 246, and it is false that it contains 264. Now I did specify hash set here because I want to make sure it doesn't use a tree set. Tree sets have logarithmic lookup and logarithmic inserts rather than constant time, which is slower, but the upside of a tree set is a tree set will keep the items in a sorted order, so you can iterate through them in a sorted order. Right now you'll see it's 135, 246. Let's change the order. Notice it's still 135, 246, because again, it has a built-in hash function, and for whatever reason, it just happened that 135 is going to occur before 246. In this case, regardless of what order you put them in, we're getting 135 before 246. As there get to be more items in the hash set, that may change. So we can't rely on this following any particular pattern. But as far as enforcing uniqueness, it's working. Okay, so now we're on to C++. Now, C++, unfortunately, is going to require a little bit more hoop jumping. I went ahead and constructed an example that uses vectors. I feel like most people are comfortable with vectors. However, you will have to write your own hashing function. I mentioned a little bit in the introduction, what happens when you are inserting is it has to turn the object into a single number that it can use as an index in some sort of an array. What we need to do is we need to take our vector, which has multiple numbers in it, and turn it into one single number that represents that. A very easy way to do that would just be to add all the values of the vector together. The problem with that is that then 1, 2, 3, 3, 2, 1, 2, 3, 1, any order, whatever it's in, including 2, 2, 2, are all gonna generate the same number. What I did here is I am taking the first value as is. So in the case of 246, it would just be 2. I'm multiplying 1,000 times the second value to make it 4,000, and I'm multiplying 1,000,000 times the third value, in this case, 6 million. So 246 will become 6,004,002. Now this isn't perfect, but it's gonna reduce the number of duplicates a lot. For example, 264 is gonna be 4,006,002 instead of 6,004,002. So it'll be unique enough, and in this case, as long as all three of my numbers are less than 1,000, this will work. Now, if my numbers end up being more than 1,000, we might have to come up with something a little more creative. Size t is guaranteed to go up to at least 4 billion on a 32-bit system. In this example, I've created a struct called vector hash, which has a size t operator. That means that it's an operator that's going to return size t. It takes in as an argument const vector size t by reference v, and is a const. What we're going to do in that function is get the three values, v0, v1, v2, do some sort of math to them to produce a single size t value, and we're going to return that. What we do then is we create an unordered set of vector size t's. A vector size t will be a vector that holds size t items, and it will take in vector hash. The hash set will then insert a vector of 246, a vector of 135, and a vector of 246. I'm then going to iterate through them and print them out just so we can see them. And then I'm going to output whether or not the hash set is able to find 246. Now this is kind of a big statement, but you can put this in an if statement. If hsFind vector size t246 not equal to hsEnd. Let's go ahead and compile this. Now one other thing, depending on how you're compiling, we can't use make for this. We have to make sure we're using C++ 17. I'm gonna clear, we're gonna walk through this process. So, we need to compile using something a little more sophisticated than make, and here's why. If I do make set example, I get a bunch of errors. I'm using a lot of tools that are not available default with make. I'm using, I think it's probably a 2006 compiler, which is what's default on the system, but we need to specifically use clang and set the standard for this to work. So clang ++ standard equals C++ 17, output to set example.cpp. And if you're working on, Visual Studio Code or something, you don't have to mess with any of this. This is just something, an extra hoop that I have to jump through because I like to punish myself. So, and we'll do /set example. And then once again, you can see it's printing out 135, 246 uniquely, because that's what's in the hash set. 1 because 246 was in the hash set, which is true. 0 because 264 was not. But again, we're not worrying about the order with this. We're just worrying about uniqueness. Okay, guys, that's how you can use sets on C++, Java, and Python. Hope it helps you out, and I'll see you on the next video.